Good morning, everybody. Happy to see everyone here, and I hope you will enjoy what I'm going to talk about. I don't think I'm going to invent anything today. I did not create, discover, or invent any of those methods. I rather want to make a point about their value, about the fact that they are not always used when they could be useful, or at least they are not always tested before possibly using them. And I also want to make a small point about the similarity and the closeness between factor analysis and correspondence analysis. So they both belong to a certain family of methods. They rely on the same core mathematical, statistical principle. And sometimes one is good, the other is better. And it's good to have them in your toolbox. So that's the approximate times I've thought about. Discussion with you is not 2 is 20. My 0 is dying, my E is dying too, so I might have to change this computer, the E, because English and another language I kind of try to use. All right, so the introductory part is about a sort of attempt to map worlds in what I call data analysis. Others would not agree with that, but so this first slide, I'll be quick on it, was prepared for another panel a couple of years ago about teaching data analysis. It does translate to research somehow. The two work together. But I was trying to explain that the top-down approach, it's a very abrupt qualification for it, has certain characteristics. It insists on some aspects of this whole nebula of things that you need to put in your bag when you go for a data analysis trip. And it's possibly most often named as econometrics. And there's another tradition which is more from the social sciences, which is a bit more bottom-up and is a bit more laid back, less formalized, less insistent on equations. And we have a newcomer, which I qualify as algorithmic, from computer science, data science. We'll have the Methods Cafe after this, and I've been asked to facilitate the one on statistics, which seems to belong to the first and the second world, and that one will be a separate community. So unfortunately, if you go to that one, the other Methods Cafe, you might not see me. I'd like to be in both, personally. I like bridges. My point in that slide was that that comes with different ways of doing data analysis and ways of teaching them, and this third where I was interested because it gives a chance to different brains to enter that world. People who enjoy coding without having a great taste for equations, and they can use this more pragmatic DIY approach to data analysis. So I'm going to follow on that with now well-known critic of the top-down approach to things. So there are certain things that you focus on when you have this approach. Numeric variables as abstract entities. There's a whole critique in the social sciences methodology literature of variable-centered data analysis. You don't see gender knocking the door and say, "Can I enter and attend?" You don't cross age in the street, right? You see young and older people, you see men, women, people who don't define themselves as such, and so on. So that's a radical, somehow ontological critique to that, but there is something interesting to take. Causality is also something that on which these different worlds disagree on. Insistence is put in the top-down approach on model-embedded causality. That's my formulation, that you need to have a number at the end inside the model. I mean, just the output of the model that tells you how well you can conclude on the relationship between A and B, okay? When you can do that, it's nice. I think this is fairly rare, although it's predominant in practice. It's fairly rare because causality often needs more than the model. The model is just one of the components that enables you to conclude or not to a certain degree to causality on a certain research question. So there are a few more things, including the constraining statistical conditions of application. People know about that, but they tend to keep that under the carpet because they are difficult to test and to have validated. And that has consequences on the choice of topics, on the formulation of research questions, on your capacity to really investigate, while there would be other approaches, the other two worlds, that could be more relevant to your research question. I've got a graphical version of more or less the same. So that's the classical approach to variable data analysis, variable-centered data analysis. You look for the relationship between A and B, and then you have complication with A's and C's and D's and E's and regression modeling. If I talk more specifically about a certain method, reasons on pure variables, and search is ideally for the pure effect of each variable. And I'm trying to take the angle of what is sometimes called multivariate data analysis. There's a great book about that, a great handbook, Bartholomew and colleagues, and they use this term, I think. So it assumes that measures are really independent and variables really pure. And then your interest is to work with those gray areas where you have overlap, okay? So dependence or interrelations between variables is not a complication, is not something that you want to take off the picture. It's precisely where things are interesting, okay? These little tables tell you more practically how the search for purity is implemented with these measurement issues and collinearity issues. We spend a lot of time on that. I'm not saying variable-centered reasoning is wrong. I'm saying it's not giving you the whole picture often, right? So now I come to the first method I wanted to refer to. It's not new. It's not something that came after or in reaction to. No, they developed in parallel, but they took sometimes some fairly different path and did not meet as often as they could have. So factorial analysis, I'm taking this example of the psychometric test, which is, well, psychologists are the ones who use factorial analysis the most. They are very good at it. They learned that from year one at university because they need it, right? And maybe I take a picture of a guy who contributed largely. Looks glorious, right? He did a good job, I think, setting up this method. So what is it? It is a multivariate method, okay? The social word is multivariate, multi-causal. Focused on the structure of data, a bit like cluster analysis. If you've done that before, then the move would not be too big to make. Inferential purpose under certain conditions. Requires P continuous variables, okay? And there should be some degree of correlation between those variables because we're going to be interested in the zones of overlap between those variables. It is a data reduction method. Some textbooks of data analysis are named actually data reduction. It's interesting, right? And all methods are somehow some summaries of your data. It extracts latent factors, that's an expression, or hidden factors, which we call Fs, okay? 1 to Q, Q is smaller than P, Q, as much as possible, is much smaller than P, so we reduce the dimensionality. And the key principle for the whole session, if you like, is this. Okay, you can factorize. You've learned that in in high school, maybe elementary. Okay, so the 5 is what we are looking for. Okay, the bigger the 5, the better the job we can do. Sometimes this factor, this common factor, is very small, so it's there's not much overlap, not much commonality. But here we have a very simple intuition of what we are doing. Okay, so the F's summarize the variance carried by the V's, and by construction, the F's are orthogonal by pairs, pairwise. Okay, which is interesting because when you want to fit that into regression models later, then orthogonality is something interesting. We don't always keep this orthogonality at the end of the process, but we start with that. Okay. Is it a magical method? Okay, that's a quick formulation to say that hidden factors may reveal something that is really expected by theory, or it can help and define and quantify a known phenomenon. I'll come to that example later. That's a historical application for which factor analysis is known, again, psychology, or help identify the common dimensions of observed social characteristics. You have a few examples here, so it would be best to see that through examples. Okay, so I've got 3 examples. I'm just developing one here. So the idea initially was that this guy, Spearman, was looking at marks and other measures of achievement for students in school, and he realized that often you had some good students who were doing well across the board, and then some other students were doing badly, or medium across the board again. And so it was either a bias of subjective bias of teachers and markers who would say, okay, these are the good students, these are the bad students. That may have happened, but it's not only that. There are commonality. There is a level of commonality between students' achievements in school. That's just one example. And then he proposed to call that intelligence. He was not the first to do that, but then to try to test that empirically. And the idea was to extract these common factors across the different subjects that students were learning about. And then this theory of intelligence was fine-tuned, and we found that, or we confirmed somehow, the intuition, which was already there again, but just theoretically, that there could be several types of intelligence. And factor analysis can help you extract those different types and characterize them. If your data are sufficiently precise and diverse, of course, you need a questionnaire that is strong and large and well conducted. Okay, so that's a key example, and the intuition is there. And I've got a few more examples. You can find the papers if you wish about attitudes. My interest is in environmental politics and attitudes and behaviors. So I've tried to focus on this. All right. So what is the workflow? To give you a concrete idea, I'll try not to spend too much time on equations, neither on this or the next method. The next one is less well known, so it would go even a bit more complex. You'll find other ways to. In an hour, I can't go that far, but I try to give you the workflow. So again, identify your V's. So observed variables. Often, typically in surveys, they belong to a box. Okay, you have like, what's your views on this and that policies? Or do you hold this and that values? Or have you engaged with this and that kinds of organizations? Okay, do you have this and that affiliations, and so on? Sometimes they are not designed as a box like that, and they appear in different places in the questionnaire. But they have to be related to a certain concept. That's important. Think about intelligence again. You need to have a key theoretical target. You can't take random questions in a questionnaire and then have a big, exploratory approach to that. You can do that with cluster analysis much more easily. But with factor analysis, no, it doesn't fit with, that's not the purpose of the, you would find weird results that you would not be able to interpret. Okay. Verify their empirical association, again, the question of overlap. So not null, not perfect, and then my students say, wow, so not 0, not 1, but we very seldom have a 0 or a 1. That's true. But it has to be somewhere in between. Okay. And then you can have various kinds of correlation tests, and some are cluster correlation tests. They can summarize the level of correlation within a whole matrix, which is convenient. We have very straightforward tools for that. And then this is the model. That's the only equation for this method today. So it's maybe not fully intuitive, but you formulate the observed variables in terms of the hypothesized factors, the Fs, okay? And it's a linear model. Straightforward. If you've done regression, you understand what I'm talking about, okay? And we want the Fs to be standardized again, so the mean will be 0 and the standard deviation will be 1. So that's quite convenient for what we want to do. And we call the alphas the factor loadings. That's the conventional expression for it. And we'll work on the factor loadings when we will interpret the results. Okay? So if you look at those parameters here, then the alphas are correlation coefficients. So that's convenient. We know how to work with correlations.
Just a question. If the factors are meant to be latent or hidden, how do you already surface them at this stage? Yes,
we work the other way around to calculate the factors, yes. So we'll have algorithms to estimate the Fs depending on the Vs. So we'll be able to reverse the equation to calculate the Fs from the Vs.
And then you have to be able to say what the F is.
Yes, we're going to calculate. Yeah, those. So the Fs will come up as scores. So we'll calculate the factor loadings from which you'll be able to assign a score on each factor for each individual in your data set. So this calculation is done by various methods. You might know maximum likelihood. It's fairly standard in regression estimation. And that one can be used. That's the one I've used with my R functions. I list them in one of the last slides. But there are other methods, ordinary least square or generalized least squares. And then the Fs can be expressed in terms of the alphas. I don't have more equations to show you on the slides about this today. But those estimation methods can calculate that. So let's work through examples. Here again about the schools for an introduction. Students in Wales were tested on 6 subjects. And you have 2 Fs here. And typically you find the first factor. So the first factor is the prominent factor. The second factor is orthogonal to the first and takes charge of the variance. The residual variance after factor 1 has been calculated, okay, and so on. So the variance, the size of the factors decreases typically like this, fairly quickly, okay. And the first thing you find is what Spearman had in mind, is that there's a general ability to do well at school, okay. You might have observed that yourself as a student or as a teacher. Some people just fit with the institution. Or the institution chooses them, or whatever. You interpret that. So you may find that interesting, and it may be interesting to know the prominence of certain subjects within that general aptitude at school. Okay? So here, being good at these two seems to predict well your general ability to feel good at school and then perform well across the board. And then what's interesting is the contrast you find in the second and subsequent factors. And here there seems to be a contrast between these three and those three, and you see where this is going. Negative and pluses are arbitrary. You could exchange the signs. It's just that there is a contrast between those two groups. Okay, so we'll work like this on contrast or divides. And this is an axis. You have an axis that ranges from minus something to plus something, and each individual has a score along this axis. And then you can see the kind of graph you can make from that. Okay, a two-dimensional graph, which is the typical representation on factorial methods. So maybe another example that I like to use is about the usage of different kinds of media. And you start with correlations, that's the core plot function. These data are a bit more than 10 years ago in the Netherlands. This choice is a bit arbitrary, but you can see some fairly logical positive correlations across the board, but especially between certain internet-based, internet and mobile, actually. So more modern technology. And then you've got these more classical media, which are likely correlated. And daily was in that survey. We could have taken it off, but we kept it. It's about daily interactions in person, conversations. Is that a medium or not? You can decide. This is the theory tells you that. You can decide what you put inside, like any kind of data analysis. So first step is to check that you have some degree of correlation between your variables. And then this is the output of these are the factor loadings on the first two axes with three different algorithms. So the first one is the default one I've mentioned earlier. Okay, orthogonal factors with no tweak, if you like, which tends to give you a strong first factor with everything correlated with it. It's doing well across the board at school. And in this case, it's about using a lot or little across all media channels. Okay, all media, yeah. So that's the axis, and then the Y introduces some nuances between those things. So email is opposed to TV. So email, you can see what's the behaviors behind. So email is more professional, is more like sitting and doing something, while TV it tends to be more passive. So you can maybe understand those contrast. And then the correlations that you had initially by variate indications are kind of confirmed here, but multidimensional is more powerful, so it gives you more. And this graph has been elaborated with some tweaks. So maybe I can switch directly to those tweaks. So they are called rotations. So rotations is tweaking the geometry where you can move the axis in order to cluster the variables better. Okay, and these tweaks can preserve orthogonality on the left or give it up, which means your Fs will not be orthogonal anymore. You may decide to go for it or not. If you want orthogonality, you stay with. So on the left is Varimax. On the right should be Oblimin. So we have quite a few rotations like that. So let me go back to those graphs. So you may go for one solution or the other depending on what you're looking for, depending on what sense the rotation you choose makes for you, and depending on how insightful the results are. Okay, so that's the classical come and go between your parameters, your results, and your objectives. Okay. Another example is about confidence in kinds of institutions. So here we have 20 types of institutions in the same country, and the same period, the same data, European social survey. And you can see some clusters already. So this is a structured correlation matrix. So we've used cluster analysis to put together those types of organizations that are trusted versus non-trusted together by the same individuals. And typically there's a cluster around political authorities. There's something around the environment, women, and other kinds of charities. You have the press and TV up there. And you've got some more economic or state-related organizations here again. So correlations, again, are preparing your analysis. And then when you take those, we call those scree plots, you can see how things are organized better. And on the default options, you've got the churches quite separate. So you seem to have a community of relationship in the Dutch society at that time, community of relationships to institutions that isolates churchgoers or people who trust the church, and the army too. And then you've got the political institutions and a block of things that are not very distinctive here. And maybe you can see better when you go there. So typically the rotations, again, clarify the results in the sense that they give you some better isolated clusters of variables. Hence behind clusters of individuals, although we are not doing cluster analysis here. That can be done downstream if you wish. All right, so let me try to move on down on the workflow so you can assess the model. Do the factors make sense? It's important to be able to name what you obtain. The factors are sometimes, again, a beautiful discovery or a beautiful confirmation of the theory. Wow. Like the relationship to Europe versus the nation is a new structuring political ideological factor in some European countries around the Maastricht Treaty, and again later around Europe-related referendum. And you can verify it versus left, right, liberal, conservative. And it worked brilliantly in some contexts. But more often, you're discovering the factors, you have to make sense of them. As usual, you need to know the context. Understand well your data and know the context in order to interpret those things. Are the factors heavy enough? This should not be an exclusive criterion, but part of it. Are the observed variables explained well enough by the factors? So sometimes a factor will be defined by, for example, TV versus the rest of the world. Does it make enough sense to you? To me, yes, because TV is a certain practice. I remember my grandmom having TV on the whole day. She would not read the newspapers. She did not have the time or the interest for that. She would not really read the magazines. She would, no. And that was structuring her life. But in other contexts, sometimes it can be a very, very marginal result, maybe so marginal that you can't interpret it. In this case, you can just drop the factor. Don't take off the variable off, but don't spend too much time interpreting that. Okay. And how many factors do you want to retain to have a comprehensive analysis? You may intend to have a comprehensive analysis or not so much. sometimes you want to explore and you want to understand the structure of relationships to institutions and confidence in them globally. So in this case, you may want to go down to as many factors as is needed, or as many as you can interpret, maybe. So you can go up to 6, 8, 10. Sometimes you have a more precise hypothesis about the existence of a factor or the size of already factors that are already announced by theory. Then you can stop at 2. Sometimes 2 can give you a high percentage of variance explained. So we have scores for that. Okay, and improve the model, delete variables that load too little, for example, and use rotations. So I've shown you these graphs already. That's another example. I prefer to move on to correspondence analysis, and then you can link that into other treatments. Okay, so let's move on to correspondence analysis and a couple of illustrations. So that's the typical kind of thing you see in papers that use that intensively. I quite recommend the first author on the right, Felix Buhlmann's work in terms of using together these different non-standard methods. So they would often use correspondence analysis together with network analysis and a bit of clustering too, and get some very insightful results on typically the field of power or the field of an economic sector in a given country, possibly comparing countries. And what you can see here are not variables, but groups. Again, what really exists according to this guy. So he was the, old and wise. So this guy devoted most of his life to that thing. So he was a mathematician, but he did meet some sociologists at some point. And he elaborated that method of correspondence analysis based quite intensely on graphs. So what are the assets of that method? It's multidimensional. Obviously, it puts description first, precise and near exhaustive. It's favoring induction rather than deduction. You may have hypotheses. You will most of the time have some hypotheses, even if they are subconscious, so you dare not formulate them, or you're not sure how to formulate them. But the method itself doesn't assume anything theoretically. There will be choices in the pre-processing and the choice of variables, of course, the way you format your categories, you divide your variable, and of course all those things are based on your understanding of the topic and the hypothesis that you're making, fair enough. But the method itself will not add up in this respect. Allows extension to hypothesis testing, formalization into mathematical objects and geometrical objects, so you can use spatial intuition. Come and go between the 3 levels, so we'll be able to materialize individuals, groups, clusters, and the whole sample. So that rehabilitates individuals, which are pretty much ignored in regression analysis, except for excluding some of them, the famous outliers or too heavily contributing individuals. The difference with factor analysis is mainly 8 here. We can take all kinds of variables, including categorical, and that's powerful. Again, factor analysis was strictly continuous, which is a limitation. You understand the spirit of those methods. They encourage you to go deeper into the discussion about, is this variable categorical, ordinal, or continuous? Can it be 2 of those, or even the 3 of them? And can we compare treatments using one or the other? And there's no shame doing that, and you can find slightly different results with different levels of measurement for the same variable. It doesn't mean any is wrong, right? And that method is integrated more and more to those methods from the third world I mentioned at the very beginning, for text mining and lexicometrics especially. So it's a method of choice for text as data users, and for good reasons. So the principle is starting by looking at frequencies and cross-tabulations and multi-way cross-tabulations and chi-squares between categories and between individuals. And that gives you an idea already of the structure of your data. That is, how correlated a group of something is with a group of something else. We mean with certain professions, age category with certain values, and so on. So we often start with those kind of things. For example, this cross-tabulation, which is a contingency table. So you have 5,000 people, and they are spread like this across those two variables. So a contingency table is the main thing we start with, the main thing that we feed the computer with correspondence analysis. That's a trivial example about the relationship between hair and eyes colors, but it gives you a good insight into what the method can do. So data can be classically opinion, vote, attitudes, and we add up sociodemographics. So you find the superstructure, infrastructure that is key to the analysis of social classes. May also be groups, organizations, geographical units. Text, as I mentioned, and we have several software that integrate correspondence analysis about text. And formally, any table of non-negative numbers. So it's quite versatile. And there are two ways to do that, which are very close to each other. You can start with a bird table, which is a cross-tabulation between two categorical variables, or you can work directly on your classical individual by variable data set. Okay. And the key mathematical concepts are matrix diagonalization and factor extraction. There used to be a manual approach to that, which is make a big table on paper that includes, so it's a symmetric matrix that includes all your pairwise cross-tabulations between all your variables. Okay, so if you have 10 variables, on average 3 categories for each, and you'll have a 30 by 30 table. And you have this on a wall, and then you cut all the columns and cut all the lines. And you try to move your rows and your columns in order to get together the largest values. Okay, the largest cross-category groups. And this approach represents in some way what matrix diagonalization is. So let's take an example to see what it looks like. So that's a survey passed among party members in Morocco a bit more than 10 years ago. A fairly large survey, very well designed. I have no merit. I was just associated with the data analysis part of this. And one of the many questions in this long questionnaire, there was a lot of work to get people to answer the questionnaire, to understand the questions properly, to let them go to the end. Not everybody was literate in there. But this one is a precious question where they were asked, so party members going to a congress, they were asked, among those, there's a lot of parties in Morocco, and there's the king somewhere in the middle, in the background, looking, organizing, pulling, pushing. Okay, maybe you understand the logic. And for each of those other parties than the one you belong to, is it an ally or an opponent or something else? Okay, each time one choice. So it looks like this, okay, red tick. And the hypothesis is that those bottom-up data, grassroots views, will tell you better about the antagonistic logic in the party system than what you observe at a more general level of the relationships between the leaderships and so on. Okay. Okay, we do that. So here we have simple frequencies which don't tell you much because they are not multidimensional, right? But they give you a sense of the volumes and already how spread the views are on each of those organizations. And correspondence analysis is both systematic and comprehensive in the sense that it's going to treat the data for all those variables together. And it keeps in the nuances in the sense we're not going to collapse columns 3 or 4 on 1 or 2. We're going to keep the 4 of them in the picture. Okay, so it's not binary. It's a 4 category. Each of those columns may mean something. Okay. Additionally to the core process of diagonalizing the matrices and calculating the factors, we have the concept of distance, which is clearly defined with fairly simple arithmetic, actually. Clouds of modalities or categories, clouds of individuals. Powerful stuff is that you can project together the 2 clouds on the same map. Maybe you've seen that before, you've been puzzled. Well, it does work. There are critics on this, but it does work. And you can calculate the contributions. So how much an individual, respectively a group, category, contributes to a factor. And reciprocally, interestingly. So you have big listings of numbers at the end of the day to work from. And you have to dive into that and spend hours interpreting. All right, and that looks like this. So you have this concept of distance that tells you that the further apart 2 points, the less people tend to consider those 2 parties the same way. So both allies or both opponent or both none of the 2 or both, what was that? No answer or something like that, okay? And then we can distinguish clouds and we can apply cluster analysis, okay? So here you can only see the categories, but the green clusters are clusters of individuals. So any individual can be positioned in this landscape of categories, okay? And each institution in black, it's either an opponent or an ally, okay? And in red is the organization to which you belong as a respondent. Okay, so 3 kinds of things here, plus the clouds. Those green lines were done manually. But you can project ellipses of confidence for each of the red dots here, so the parties you belong to. And you can see where they stand. So I don't have the time, obviously, to explain these different things, but you can see Attack here, which at some point was a major actor in that Moroccan party space, and some leftist S is for socialist here. So yeah, the left is more or less here, the conservatives, not sided, which is an important thing, because being in or out the system, political or not political, is important in this whole balance and harmony that the leader in the background is kind of monitoring. Okay. And here you can project what we call supplementary variables, which means variables that were in the data set. We had many more than 17 questions, actually 50 or 60. So variables that were not active, not used for calculating correspondence analysis, but that can be projected. So you can calculate where those people who declare themselves as not religious at all, which means something in Morocco, modern Morocco still, where they stand typically and close to the left. So that positioning is not a surprise. But when you look at those kind of results, you're looking for surprises, right? You don't want to just confirm what exists. Sometimes confirming is important because nobody has done it before empirically, but sometimes it's important to. Yes?
Thank you. Let me just play devil's advocate here. What's the benefit of this method compared to exponential random graph models? Because if we were to view this as network data, we could run an exponential random graph model, and it would be much more straightforward to interpret.
I don't know.
You know.
Can you explain exponential random graph? Is this inferential network analysis?
Yes.
Okay. I'm not sure, so I prefer not to answer.
Okay.
Sorry. But if you can elaborate, maybe we can discuss. Do you see? Do you not see a difference?
I just feel like it would be easier to interpret the output, because if you could go back to the previous slide, to be completely honest with you, I don't understand how all of the levels that you described, the individual group affiliation and the sort of ties between groups that the individuals express in the survey, how they can be displayed in this one graph. This is something that I don't understand.
Yeah.
And it's probably my fault. But if
No.
we were to convert this to network data,
Yeah.
it would be much more straightforward, I think.
So you would build a network data set
Yes.
based on the same answers.
Exactly.
Okay.
And then, based on the religious affiliation data, this would be attributes.
Yeah.
And then you could run exponential random.
It's quite possible that the two methods would converge. Would they give you exactly the same thing? I am not sure. So back to correspondence analysis, yes, there is a limitation of those several layers on the same graph because they are not exactly in the same space.
Yeah.
This is true. So the distance reasoning on the black dots is not exactly the same distance reasoning as the green dot and the red dots. Yes, distance is not exact here. But cluster one, so a cluster of individuals based on the axis themselves, all of them or just 1 and 2, that's choices that you can make, are in the same corner of the graph, if you like. But distance-wise, it is approximate. I have to agree with this.
Thank you.
So that's the confidence ellipses that I mentioned earlier. So you can be confident that 95% or 90% of your individuals will be in that area, which it's interesting to see if you have some organizations that are very consistent and localized, while others are more widespread, which tells something about heterogeneity of views within the organization, which is important in political terms, ideological and political terms, and the political conjunctures, because you can add up time, typically, and then you can see ellipses going out or back in shrinking. So time is welcome on this kind of graphs. All right. Just to finish, because I'm nearly exhausted the time, sorry for this, maybe I'm too slow. So that's a survey we ran on where I and the managers of this school used to be before MethodsNet was created. Maybe you've heard of the story. It's not always a funny story, but it was great at the time, and it's great now. It's just a different context, different setting. So within the CPR, we passed a survey among all the instructors, asking them as experts to qualify the method they teach. They enjoy, they do research with usually, and so on. And most of them accepted to reply, and we asked them questions that look like this. So we had a small number, that's logic of survey, 20, and that's the 11 first. And we asked them the characteristic of the method they teach as they define it, according to a number of characteristics which may be more or less technical, more or less epistemological, and so on. And they were all categorical by necessity. So we came from these first. Initially, we wanted to provide a map for attendees to the schools to orientate themselves among those different methods and choose what's best for them in a certain order, see what's closed, see what will take some time to travel from A to B. And I built that thing, and then there were discussions like, oh, I'm not sure I stand there. It's always like that. I'm not sure I'm there. I should rather be here, or maybe in two different places. So very approximate, a bit subjective, and depending on the author's understanding of those different methods. So that's why we wanted something a bit more inductive and based on experts' views on that. Okay, you follow me? And then we came up with this. So applying the correspondence analysis, in black you have, at that time, the titles of those courses across 3 or 4 winter-summer schools. Okay? So we have about 50. And that's axis might have been 1 and 2. And of course, the question was, okay, qualitative, quantitative, and something in between, and do we have already the third world of computational methods or not? We had formal methods, game theory, and things like that. And we also had some courses that were more focused on a certain piece of software. So that was somehow a test for the wider structure of the world of social science methods. Okay. And we did confirm a lot of what I just said, but with some nuances which were interesting to note, and that's where you make discoveries sometimes. And in green, projected, are the answers, yes or no, in terms of does it fully rely on applying a software or not, and so on. So we could place each of the courses within a certain landscape of characteristics of methods in terms of research practice and in terms of teaching experience for users who were the targets of this. So that's been published some time ago, and you can have a look at it if you wish. You'll get more detail there. Okay, I'm going to skip this last example, which was again about Morocco. But I wanted to recap about the similarities between those different those two methods: factorization, dimensionality reduction. A few similar concepts of axes and maps, factor loadings, contributions. And factors are portable into other methods. I'm an R person, so you have a few packages here that can be interesting to play with. And other factorial methods that you may have used, and then you were wondering what those two would bring on top. Well, there is literature that compares the different things. For example, PCA is often used to decide on a number of factors before using factor analysis. That's an example. As usual, there's a lot of discussion about the number of clusters, the number of factors. I don't think that's very important. I don't think that's what we should spend so much time discussing. But okay. Confirmatory factor analysis is definitely the next stage after you apply factor analysis, also called exploratory factor analysis. It's not always necessary, this being said. And this is it. We can take one more question, maybe, because we have the methods cafe at 11:15. So it's up to you, actually. I hope you have something to take away from it. It's just a quick introduction. There are a few good textbooks on those things. Correspondence analysis, the less well-known one. I mean, depending which country you come from, you have Michael Greenacre, you have Georg Blasius, who is now retired in Germany, and you have Leroux and Rouanet, French language, but they have English versions too in the Sage Small Green Book collection. I recommend that one. It's compressed. But you can start with that and then go for the bigger book if you wish. And for factor analysis, I mean, it's available in many psychology, social science textbooks. Okay, thank you very much.